Welcome to the Faircom webinar series. In this webinar, we will learn how to enhance AcuCobol applications with CTreeAce for COBOL from Faircom. CTreeAce for COBOL seamlessly replaces the file system used by your COBOL compiler. It provides high-speed transaction processing, protects your data, and improves scalability. And it adds SQL access to your existing COBOL data. Let's see how it does that. In this tutorial, we will perform the following steps. Compile and run the tutorial to represent a native COBOL application, switch to the CTreeAce file system, and migrate the existing data to CTreeAce. And then we'll create the XFD file descriptor to map the ISM data to SQL, which will provide both SQL and ISM access to the same data. Before we begin, you'll need to have these programs installed: AcuCobol version 8 or later, and CTreeAce for COBOL. If you have a different version of COBOL installed, some of the commands will be slightly different. This tutorial assumes you can start the CTreeAce server and connect the client interface to this server. If you don't know how to install or start CTreeAce for COBOL, please refer to our website. I like to start by rounding up the files we'll be using and putting them all in one folder. We can create a folder called Tutorial and place the tutorial in it. CTreeAce for COBOL needs a configuration file, which you may have created when you installed the product. If you don't have one, we'll create it shortly. Let's include a copy of ctutil and a DLL used by the application. The CTreeAce for COBOL connector needs a configuration file, which tells it about the CTree server and the data files it will map to COBOL. The table used in this tutorial is called customers, so our config file looks like this. You also need an environment variable that points to that file. The variable needs to include the full path and file name, even though everything in this tutorial is local. The Faircom documentation explains this configuration file. Let's make sure the CTreeAce server is running, because we'll need it later in the tutorial. On a Windows system, you should see a service called CTreeAce Database Engine. If the service is not running, start it. We are now ready to begin the tutorial. Step 1. Run the tutorial to simulate a native application. Before we can run the tutorial, we need to compile the program. Now we see the compiled version of the program. Now we can run our program to simulate a native COBOL application. We press C to create the table, P to populate it with records, and D to display the records. This represents data your application has been gathering over the years. Notice the program has created the customers file and an index file. This is a native COBOL data file that contains the records we saw on the screen, which represents your legacy data. Step 2. Redirect the file system to CTreeAce. For our next step, we're going to change from the default file system to the CTreeAce file system. In this version of COBOL, all we need to do is set an environment variable pointing to our file handler. Once you set this variable, the COBOL runtime will use CTree. If we run the tutorial at this point, we will see an error indicating the data was not found. This confirms that the program is now looking for data in the CTreeAce file system. So our next step is to migrate the data into CTreeAce. Step 3. Migrate your existing data. In this step, we will copy the data from the existing customers table, which is stored in the native file system, into CTreeAce. We will need an extended file descriptor, the XFD, which provides information about the structure of your COBOL file. To create an XFD, we compile with the -fx parameter. Notice that you do not need to alter your source code. If you already have an XFD, you can use it, so you don't need to recompile. Next, we dump the data from the original file using an AcuCobol utility. Specify the name of the source and destination files. Now we make an empty table in CTree using ctutil with the -make parameter. Specify the name of the table and the name of the XFD file created previously. Finally, we load the data into the table using ctutil with the -load parameter. Specify the name of the table, followed by the name of the dump file, and A to add records. This created a customers.dat file in the CTree SQL data folder. We can see this table using the CTUtil tool. Step 4. Run the tutorial using the cTreeAce file system. Now we can run the tutorial again. This time it will find our data in the cTreeAce file system. The data we migrated from the old customers table to ctree is being read by our tutorial. In step 2, the program returned an error because this table did not exist in ctree. Now the table is populated and the program is reading the data from it. In these simple steps, we have told our program to use the ctree file system, and we have migrated our ISAM data from the native COBOL file system into ctree. Now let's see how easily we can add SQL access to our existing ISAM data. Step 5. Map the ISAM data to SQL. The final step in our tutorial shows how to integrate this ISAM data with the cTreeAce SQL server, allowing you to have native SQL access to your COBOL data. We start by linking an existing ISAM table to the SQL database, which is done through our CTUtil tool using the -SQLize parameter. Run the tool indicating the name of the table we want to link and its extended file descriptor. You also need to include the administrator's password, admin, and the name of the database, ctreesql. Notice that the XFD must be in the same folder as CTUtil. The utility uses the XFD to create an extended data definition called an XDD, which defines the data schema and other key aspects of the database. The XDD is described in the Faircom documentation. Now that we have SQLized, we can use cTreeAce SQL Explorer to view this data. Once we connect to the ctree server, we can see the customers table as a SQL relational table. Remember, this data was originally created by our COBOL program, just like any existing legacy data your programs have created over the years. Let's insert a new record and add some fields. We can add, delete, edit, or change this table as a pure relational database. Keep in mind, we are seeing ISAM data natively accessible by COBOL. Now we can go back to our COBOL program and read the record we just inserted. We can see the data, including the new record we just added. That record was inserted with SQL, and COBOL is natively accessing it. The data is still in pure ISAM format, so your COBOL programs access it seamlessly. Now we have the benefit of high-performance ctree transaction processing, and we have the power of accessing this data with SQL. Just this easily, you could connect your native COBOL data to an Excel spreadsheet. But that's a topic for another tutorial. That's all there is to it. We have just migrated ISAM data into ctree to provide robust, high-performance access to your data without rewriting your existing application. And we have made that same ISAM data accessible to SQL applications concurrently. Thank you for joining us in this webinar. From Faircom,